So my talk today is on disrupting the infrastructure paradigm. And that disruption, as you may have guessed, is anchored in the use of DPUs and IPUs. My name is Tim Michels, and I'm a distinguished engineer at F5 Networks. I've been at F5 for nearly 20 years, building application delivery controllers and associated networking equipment and application appliances. So we have a lot of background in this area, and we see a lot of opportunity and a lot of excitement around what we might be able to do with Diamond Bluff. And so we've worked with other members in the community to try to get this open community effort going that we had called Diamond Bluff, now OPI. And there in my cover slide there, you see a picture of the actual Diamond Bluff.
So hey, Tim, we have a request. Can you make your slides bigger?
Sure.
Thank you.
Is it really not that big?
There, that's better. Thank you.
Did that help? Okay. Okay, so I'll jump in here. So what do I want to talk about today in more detail? I want to talk about what a DPU is. I know everybody thinks they know what a DPU is, but from my perspective, looking at a DPU as a disruptive element to data center infrastructure and cloud infrastructure, I have a particular definition of a DPU. Many DPUs out there will fit that definition, some may not. So I want to clarify the boundaries around what I think a DPU needs to be a disruptive element. I want to talk about how such a DPU can disrupt the cloud infrastructure. I want to go a little further and imagine that if this disruption happens and we're broadly successful at scale, what might the end state of this DPU-enabled data center look like? And then I want to close with talking about the kind of community effort that will be needed to make this happen. I know other speakers have spoken about, focus in on one thing, don't try to do too much. But I also think there needs to be an aspect of, hey, what's our vision? Where do we hope to go with this? What can we achieve if we can put all the pieces in place and fill out the puzzle like that slide we've seen from Intel twice today? As sort of a lead-in, I'm going to use the term DPU. I know a lot of people here are using DPU, IPU. I find that awkward, at least in a verbal presentation. I'm using the term DPU broadly and inclusively. So I include IPUs in my thoughts. I include other terms. What I really want people to focus on is my definition of what I think the DPU is in the context of this disruption, and not get hung up on the specific three-letter acronym. I also want to comment on the DPU on whether it's an ASIC or a SoC or a system like a board. And I think for my use case here or my application, I'm primarily talking about DPU as a system. Yes, often there is a piece of silicon at the heart of that system, but it's surrounded by other silicon components collected together as a complete system, often as an add-in card, a PCIe card installed into a server. Is that the only way a DPU can be used? Absolutely not. I'm intentionally ignoring applications where maybe a DPU device is deeply embedded into a hardware appliance or similar system. And I'm much more focused on the broader use case of, hey, these are DPU systems on cards. They are being plugged into servers. We're going to use that to go build a new kind of infrastructure in the data center. And finally, I'll note that this presentation is very much mine and F5's perspective. I understand there are lots of other perspectives. I've been working with a lot of people in the Diamond Bluff project, and I hear their perspectives. But today I wanted to give F5's view, and so people can see where we're coming into the community and the project from.
Say, Tim, you're not sharing just your slides, you're sharing your whole screen, so it really isn't full screen. And people are asking that. Maybe you could address that.
So what's the problem, Chris? I'm not sharing my...
I can see your whole desktop, not just your presentation screen. And your presentation wasn't filling your whole desktop, so we could see all your background and everything.
I see. So I guess I could go screen share again. Oh, it must be the setting in the way presentation is working, because normally I do this and it's fine. I'll just go.
Much better.
Is that better?
Yes, there you go.
I'm sorry for that. I don't really see what you guys are seeing, so. Okay. So this is a slide that kind of shows my DPU as a system. idea, and speaking sort of against what Ian had just mentioned, I actually do view the DPU as a server plugged into a server. And I'll follow that up by what I mean by that, because I don't just view it as more x86 cores to be made available. That's not the idea here. So we see that the DPU system, as I'm defining it, needs to have general purpose compute, and that compute needs to be hefty. Why? Because I need the DPU system to be capable of hosting entire infrastructure workloads, not simple offloads closely associated with the host system. I want these offloads to be independent and hefty. The system needs to be able to boot to its own operating system on something like Linux. The DPU needs to include a mix of domain-specific hardware accelerators. And this is where it really separates itself from, it's not just a server in a server. It's a server that's carrying all of these very purpose built specific hardware offloads that allows it to do the work much better and faster and elegantly than general purpose compute could do it. The DPU system needs to maintain strict security isolation from the host server that it's plugged into. It needs to be able to have something like a TPM. It needs to be able to have its own root of trust. It needs to be able to keep its own keys and certificates secure and separate and not dependent in any way on the host system that it's plugged into. The DPU system needs its own high performance network. This is the whole point. The workloads that it's receiving are infrastructure workloads. These are coming from the network. They are high performance, high bandwidth workloads. The DPU system needs to have its own unique identity on the network. That's how it's different than an add-in card on a normal server. It looks like its own identity. It looks like its own server on the network. This makes it available to orchestration and provisioning systems that are outside in the network. It can be discovered, it can be remotely provisioned, and it can have workloads and services installed on it by the orchestration systems that are remote. It needs an independent out-of-band management capability. Again, this comes back to the lifecycle management and the provisioning, and that lifecycle management of the DPU system needs to be completely different, separate, and isolated from those on the server node that's hosting it. And finally, wrapping it all up, why do I want all this stuff? Why do I need all this stuff? Because I need that DPU system to be hosting complete infrastructure services. I went too far. Okay. So how did we end up here? How did we end up with DPUs? And I think if you back up a little bit, when we moved infrastructure services and we virtualized them and we moved them onto the host nodes, the first thing we did was we just stood them up and let them run next to their business applications on top of a standard NIC. But we saw that that was very inefficient and was consuming way too much compute. And so the SmartNIC stepped into that void as ASICs with particular offloads, and we began to pull in initially networking offloads, but eventually storage offloads and security offloads. And then the end state of this is something like the AWS Nitro solution, where they've even pulled in the hypervisor and virtualization piece so that the virtualization can be controlled from the NIC and not from the host server. And there's a lot of advantages to doing that. And to speak about those, this picture looks at it a little bit. This is a comment that calls back to Dan Daly's presentation earlier today, that one of the key aspects here is to get a bright line separation between the business applications and the infrastructure services. Leave the business applications running on the host operating system. That's where they belong. Let them be orchestrated remotely by an orchestration cluster that's being run, for instance, by a DevOps team. Let's move the networking, the storage, the security stacks down onto the DPU. That gets those workloads off of the host node. It gets rid of the noisy neighbor problems. It solves the security problem of compromised malware in a business application, compromising the infrastructure, and vice versa. There's a couple quotes there that I pulled out of Jensen's 2020 GTC speech, where he speaks to at least the problem of the compute overload that was been going on. That in 2020, they were seeing 30% of CPU cores being consumed just by the infrastructure workloads. And that as that scaled up, as nodes as host nodes tried to take on networking rates up to 100 gigabits, that was going to become just ridiculous and unsustainable. So we can see there's a lot of momentum, there's a lot of reasons, there's a lot of power behind this idea of separating the business applications from the infrastructure workloads. But to really get to this DPU disruption, it really comes down to, are you using your DPUs in a disruptive way? There are many very good, very legitimate uses for DPUs that aren't really disruptive, in my opinion. For instance, if your new shiny DPU is only providing in-band hardware offloads that are tightly coupled to the host applications, well, really what you have is the next generation, the next better SmartNIC. If the DPU's compute is only being used for hardware offload, acceleration, or exception processing, or to manage a control plane around the hardware offloads, again, I don't think that's really disruptive. That's just a better SmartNIC. If the DPU's compute and associated elements are only being used to run a closed suite of host accessible services as defined by the DPU vendor, in other words, you're getting a packaged closed system that you basically run like a SmartNIC with drivers on the host. Again, that's not disruptive. What is disruptive? It is disruptive when the DPU becomes the hosting platform for standalone infrastructure services. These services deployed on the DPU could be deployed as a service in front of an individual application running on the local host. They could be deployed as services that stand up between different applications in a mesh architecture where the different applications are on the same host, but the traffic is flowing through the DPU where it's providing its service. The services could also be stood up as multi-application, where a single service is providing offload or value for many different applications all running on the same host. A DPU is disruptive when it is used to provide standalone infrastructure services for network, storage, or security abstractions. In other words, if you take the complexity of NVMOF, if you take the complexity of having a network HSM, if you take the complexity of the SDN overlays, you package that all up, you move that as a standalone service onto the DPU, what have you done? You've made the application now very simple. It has a very elementary network interface. It has a very elementary storage interface. It has a very simple security interface. That application now is easier to develop, easier to manage, and is consistent and portable so that you can move that application around and not deal with complexities of dealing with different versions of hardware and different infrastructure services, because you've moved that particular, those bespoke complexities into the details of the infrastructure service that's running on the DPUs. So there's a huge win here for the application side of things. The DPU is disruptive. Again, when it's a hosting platform for scale-up multi-application infrastructure services. Now, this is a bit of a stretch with today's DPUs because they're not capable enough, but as we see the follow-on generations coming with things like BF4 and Mount Evans, we're going to see real traction with high bandwidth and high compute DPUs that can really take on a lot of work. And in this sense, they are capable of hosting something like an L4 firewall, a DDoS protection service, a bot detection service, an API gateway service. And they're so capable that that service is not only for their local node, because they have way more capability than what the local node can host, but in fact, they can be stood up and direct traffic for many servers that stand behind them and the applications on those servers. Finally, the DPU is disruptive when it is a hosting platform for arbitrary third-party ISV and customer provided services. So ISV is an independent software vendor. That's how F5 would play in this sort of an ecosystem. We would provide these kinds of infrastructure services. Our customers would buy them and they would deploy them on these DPU cards. That is disruptive, in my opinion. And the end users participate in this. They can go buy their favorite infrastructure services from any number of vendors, and they can write their own when they have very particular needs that are unique to their situation that no third-party vendor provides. They can stand up a dev team, go write that infrastructure service and deploy it on the DPUs. So let's zoom out a little bit. We've been down on the DPU, down on the host server. Let's back up a little bit, add a little history, and look at how DPUs represent maybe the next evolution of infrastructure services. Where did we come from? In the first generations of infrastructure and data centers, we basically built with physical appliances to provide infrastructure services. These were discrete boxes, often a box per service type, deployed across the network hierarchy. They required independent rack space, their own network interconnections, and very vendor-specific knowledge to manage each individual appliance type. This led to incredibly inflexible deployments, rife with vendor lock-in, requiring forklift upgrades to move forward or add capacity, and really high CapEx and OpEx costs that were unsustainable. This led to the next generation when server virtualization, the server virtualization wave swept across the industry. Infrastructure services were caught up in that wave. And these formerly physical appliances became virtualized appliances, where the appliance functionality was captured as a VM or is today as container pods and deployed on either standalone COTS servers or deployed as a co-resident capability with the application that it's serving on the same node. This solved many of the problems of the physical appliances, but it introduced a bunch of the new ones, some of which I have already mentioned. One of them is the management, the conflict between the management and the control between the application teams and the infrastructure teams. The DevOps guys want to run their servers. The NetOps and SecOps guys now have to get on there to run their infrastructure. And that's never a good idea to have different organizations under different management trying to share common hardware. And that's been a real operating problem at many of the customers that I've spoken to in the last several years. I mentioned also that the noisy neighbor problem exists between infrastructure and business application, as well as the loss of security isolation. So the DPU can now help to disrupt this virtualized appliance model, and we move into more of a DPU hosted service model. Why is this better? Because the DPUs don't consume rack space and network interconnects like the physical appliances did. They do share the power and the cooling, et cetera, of the host server and the rack space, but they don't compete with the business application for cores or memory or storage resources with the application workloads. They get to run on their own DPU hardware. And this is why I think the DPU should be described as a system, because the DPU needs compute, it needs hardware offloads, it needs memory, it needs non-volatile storage, it needs a BMC, it needs out-of-band management and provisioning capabilities, because it needs to really be independent. So what we see is that a DPU hosted service model, we combine the best aspects of the first and the second generations and avoid their pitfalls. And this then becomes the new preferred landing zone for infrastructure services. So where could this take us to? You know, often when I get too far ahead of my design teams, they start to tell me that I moved off into the land of butterflies and unicorns. So I want to talk about this DPU disruption a little bit from that aspect. What happens when we roll this forward if you could do the things that I'm talking about? So this is a model where somebody running a private cloud has hundreds of DPU cards out there installed. These cards come from multiple vendors representing maybe even different hardware generations from the same vendor. But when these cards come onto the data center, they show up and they access a common provisioning methods. They use common provisioning APIs and lifecycle management. They make themselves available for discovery. Once discovered, the provisioning systems deploy a common DPU software stack onto the cards. That's very important to get to this sort of vendor interoperable, vendor agnostic world. Every card from every vendor has to essentially be able to host a very similar DPU software stack, at least from an API perspective. Once provisioned, DPUs become available to orchestration systems in the network. The orchestration systems are then responsible for pushing the workloads, the infrastructure services and the workloads onto the DPUs. This could be bound tightly to the application, automation tool chains. When you stand up an application, you stand up its services. When you tear down those services. But it could also be done independently, as in I'm standing up a firewall, I'm standing up a DOS service, I'm standing up a DNS resolver that's going to be shared by many applications across the data center. I think over time we could see that the capability of a DPU hosted service is not restricted to the capability of a single DPU. With clustering technology, we may see the ability to scale DPUs jointly out as a single service hosted on multiple DPUs, where we bring DPUs in or out of that cluster in order to control the amount of scale and the amount of resources invested in it, potentially dynamically as we see the workload change, so that when the world is quiet, we run on a couple of DPUs, but when we're under an attack, our security services can suddenly scale out to dozens of DPUs in order to deal with the workload. Additionally, we may see that the DPU hosting not just a service, it may host many services. It may host many services that could be creatively service chained together to create really a composable infrastructure. These are all sort of rainbow butterfly ideas, but you can see that if we get the baseline approach right, if we take the base capability and we add the right software stack and we standardize on the right APIs and we get a community-driven, innovative environment, all of these things will happen, and potentially quite quickly, because there's so much value. My last point, of course, is you have to operate this thing, right? In order to operate it, you need to be able to see what's going on. You need to be able to debug it when things aren't working properly. And in order to get that to work, we need to have some elements of common telemetry and visibility. We need to be able to see what DPUs are available, how healthy are they, how heavily utilized are they, potentially what workloads are running on them. And having common APIs that allow access to that information allows for a lot of innovation in terms of building dashboards and management stacks behind those, and bring a lot of value to the ecosystem. So zooming back in, what is this DPU software stack I keep talking about? This is at least was an early picture I drew several months ago about what I meant by this. So we can see here at the purple is the silicon vendor layer. That's where the custom hardware APIs live. That's where the drivers live. This is the kind of area where the provider of the DPU silicon or the DPU is going to be active in providing that type of software. At the very top of the turquoise layer, that's where the ISVs, that's where F5 plays. That's where these are the applications that are going to be deployed on the DPUs once they're out there available in the data center. And to make it all happen, though, we need that pink layer in the middle. We need this open standard composable platform layer, essentially a PaaS layer for DPUs that we're not saying the open community is providing that. What we're saying is it's providing the definition of its edge surfaces. It defines the APIs for accessing the hardware. It defines the APIs for deploying and managing the applications on top of it. It includes things like how do we get a container runtime stood up? How do we do a CNI? How do we do our orchestration? What do we do for access control, policy control? How do we do lifecycle management, platform services? How do we isolate potentially different application tenants from each other? Lots of work to do there. And I actually think that's the center of the community work right now, probably over the next year or two. There are really two paths in front of us here. So this is a bit of a cautionary slide, right? There are two ways that I can see this DPU innovation path or DPU disruption path going. There's the walled garden path and there's the open community. And I sort of shaded from green to gray as being easy to difficult. Gray is difficult. So the walled garden is alluring because it's the faster get to market, easier to support. And so by walled garden, what I mean is one or two vendors collaborating basically to create full stack solutions that customers adopt whole cloth. And so yes, that will get you to market faster. It's going to be more tightly integrated. You're going to get the support of that vendor. But now you move into the gray, right? You're back to where you were with single vendor lock-in. Over time, the vendor will slow down his innovations. You're going to get limited and selective innovation. He's going to choose to innovate in the areas that address the largest TAM that he sees, maybe not including the capability that you're hoping he adds. If we get at two or three of these vendors competing against each other, we end up with a very balkanized marketplace. We've seen that in new markets in the past. And we know that over time, what that tends to do is to slow down innovation and limit the power of the technology. So the other side is open community. Now, the open community path, the hard work is up front, right? It's slower to evolve. It's hard to reach a critical mass in the industry with the community's work. It's harder to support. We need system integrators who are going to step in and say, yes, I support the community implementation and I will help the customer with his needs in that area. It's going to require sustained contributions from a full spectrum of companies. And it's going to take some risk-taking early adopters to say, hey, we know this is going to be difficult because we're the first to do it, but we see so much value in this, we're willing to do it. We're willing to be the early guy. We're willing to take the lumps. But we move into the green and we start to see, well, this is going to be inclusive of many efforts across the open source projects. We're going to leverage many of their capabilities. We're not going to invent new things that already exist. We're going to incorporate them. We're going to collaborate with the other open source projects. We're going to try to build an ecosystem using every tool we've got and then only invent the pieces that we need that don't exist. Ultimately, we can end up with a rich ecosystem of silicon, PaaS, and ISV vendors, collectively driving innovation and flexibility, along with the end user customers also contributing to make sure that their niche use cases are taken care of, right? They can come in, they can extend the API to include their use case that maybe in a walled garden environment, because of the small TAM, the walled garden vendor wouldn't even think about it. So finally, the Diamond Bluff. I mentioned that at the beginning. I think everyone today has called it OPI. I'll catch up to the community on that name here soon. But these are the goals, right? This is what we're trying to do. We want to create a community-driven, standards-based open ecosystem. We want it to be vendor independent. We want contributions from all the silicon, all the systems, all the PaaS, all the ISVs, and the end users collaborating together to really drive this DPU, IPU-like technologies out to be all that they can be. We want to create vendor-agnostic frameworks and architectures. We want to have a system integration framework. We want to have lifecycle management definitions. We want to have telemetry and visibility APIs definitions. As I mentioned earlier, we don't want to invent where we don't have to, so we're going to reuse and only define where we need to. But we want to get to a common set of APIs so that all the elements of the DPU ecosystem can be addressed. And finally, and most importantly, we need to provide implementation examples to validate that the architectures and the API definitions that we're producing are sufficient and actually achieve their end goals, and provide examples for other peoples to build upon, a starting point, and give people confidence that if they adopt the Diamond Bluff or the OPI way, that it will work out for them. So finally, this is a call to action. You know, if you're out there and you see that you could play a role in this, you're concerned that maybe your needs won't be met, you know, step up, send a couple of people to the meetings, get involved. If nothing else, you'll learn what we're doing, and probably you'll end up contributing more than you think. So this is my ask and F5's ask to join the OPI community and help us build this thing and take it into a bright future. Okay, I think that's it.
Okay,
Well,
thank you,
Tim.
Tim.
Questions, Susan. I just want to make a point. Anybody who's confused about IPDK versus Diamond Bluff versus OPI, the history and the naming and where that's going, come to the closing session today, and we're going to go into that. So just letting everybody know.
Thank you. Okay, Tim, couple questions for you.
Okay.
With your definition of the DPU as a complete independent server within a server, what is the advantage of having the DPU in the server rather than deploying it as a discrete separate server?
I think the advantage is that you don't consume your own rack space, right? You get to leverage that 1 U of rack space.
Okay.
That's one of many advantages. I also think there are cases where the DPU may be used by the local applications in addition to the hosting of the standalone infrastructure services. So, and I think because of the the way that the community, or sorry, not the way, the way that the industry has gone with wanting everything to be a heterogeneous server, you can't, it's difficult to just show up and say, oh, this is a DPU appliance and get anywhere with that.
Okay, we have a couple more minutes. On your DPU as a server slide, you explicitly called out both the need for a deep TPM and basing identity on the primary network interface. Why was the NIC chosen as the source of identity as opposed to the TPM?
Well, in that picture, I think the TPM was on the DPU. So I don't think a TPM provides an identity. Maybe I'm confused about that. I think a TPM is more there for measuring code and signing code. I mean, I don't want to get into a root of trust conversation, but by network identity, what I'm really saying is that the DPU needs to have its own IP address and be visible as its own endpoint in the network. That's separate and distinct from that of the host.
Okay, one more question. Seems like F5 thinks there is a space for a full revolution where it's possible to have a homogeneous DPU environment. Is that what you advocate?
Homogeneous in the DPUs are everywhere, but heterogeneous in the DPUs aren't all the same. They're from different vendors, potentially. They're from different generations, and they're blended into a common fleet. The only way this can happen is if you roll out 100 of them, and then the next year you roll out 100, and then you roll out another 100, and they're all different, but they're all capable of coexisting in the same DPU ecosystem.
Alrighty, next question. The infrastructure and application host have a security boundary in the model Tim's talking about. That means secrets for, say, tunnels and encapsulation, decapsulation, that should not be part of the root of trust. Is that something? Oh, sorry, that wasn't a question. I just started reading it off. Do you agree with that statement?
There's a lot to unpack in that statement. I think the main thing about the security separation is that we want to make sure that whatever code is running on the host can't compromise the security of the DPU. It's another conversation to talk about whether how do you create security isolation between potentially two different services that are coexisting on the same DPU, because that gets you back into the same problem that we have on the host, and is really still largely an unsolved problem in the industry. So at least we can get business application separation from infrastructure.
Great. We are at time. Thank you, Tim.